Hello folks, we're going to do a plan for Quant, how to go about Quant, like a 200-day plan for how do we approach Quant, how do we have a crack at this entire animal called Quant, right? It is one third, LRDI, Quant and verbal, but probably from a preparation point of view, more time for preparation is going to go on Quant because the syllabus for Quant is vast. So for LRDA or verbal, there's practically no syllabus. When you read a passage, you answer questions, you can't learn for verbal. Right? So likewise for verbal, likewise for logical reasoning, but for Quant, there's trigonometry, inequalities, functions, percentages, ratios, it's vast. So preparation is going to be dominated by Quant. So I'm going to spend time on topic on analysis of how to plan this animal called Quant preparation. Right? So before we go in there, I want to talk about what does this what goes into Quant. Typically about 40% is arithmetic, which I've done the last few years. 40% is arithmetic. Nearly 20% is algebra. About 20% is number system. About 15% is geometry. And my 40, 30, 20 and 15 adds up to 105. As a math teacher, it shouldn't add up to 105, but you get the gist of it. Talk about nearly 40%, nearly 30%. Right? So important points to note here. Probably this number 29% is probably overshaded a little bit because lots of times whenever there are x's and y's that come in there, I classified them as algebra. You can't really crack this algebra without having a super sound basis for this and this. And so if there's a question that says let a and b be two prime numbers, then a square plus b square is this. Without understanding how prime numbers behave, you cannot solve. Right? So algebra is slightly per se more advanced thing because algebra is like add x and y to the other things that you have learned. Then it becomes algebra. The algebra has pure algebra questions and then questions from pipe systems or number systems that have x's and y's, a and b's thrown in them. So it's something to just keep in mind. And also while understanding scores and marks, if you attempt 40% of the paper, if you get whatever the total marks for Quant is, if you get 30% of that, 40% of that, you'll cross the 90th percentile. So there are 22 questions in Quant. If you get 9 questions you attempt and get 8 of them right, that typically crosses the 90th percentile range. Right? If you get 14, 15 questions out of 22, you're at 99 plus. Right? And if you get 16, 17, you're at 99.8, 99.7, that range. And so it is very much possible to know only this, be comfortable only in this, and get 90th percentile. Right? It is possible that you crack these two, you get 99.4, 99.3. Just to keep it in mind. Right? What goes into arithmetic? We talk about percentages, profit and loss, ratios, mixtures, speed time, races, pipes and systems, work and time, simple interest, compound interest, averages. And on top of this, a couple of topics like exponential, logarithm and progressions that can be technically classified here or here. In this pie chart, I put them here, but they can go here also. They can go both ways. And so all of these go into arithmetic. What goes into algebra? Linear and quadratic equation, inequalities, functions, polynomials. These go into algebra, which is cubics and higher order power equations. So these 4 or 5 topics go into algebra. Anything with x and y layered on some topic here also gets classified in both cases. What goes into number systems, modern math put together, everything with numbers, HCF, LCM, factors, factorial, reminders, all of that, the whole shebang. Then permutation, combination, probability, a little bit of set theory, Venn diagram, so that goes here. What goes into geometry? Just geometry plus geometry, trigonometry, mensuration, coordinate geometry, that goes here. And so any preparation plan that you have for this exam has to be absolutely completely founded upon or laid, the foundation stone is arithmetic. And do not bypass arithmetic and go here. Be the king of arithmetic. Be the absolute doyen in this before adding any layer to it. And there's no ambiguity at all in my head in terms of what is the route to 90th or 95th or 99th or 99.5 percentile, whatever it may be. The route to that, whatever may be your target, is to become king in this. And so if you're naturally good at math, if you've done an enormous grind for JEE preparation, if you've done very comfortable with the conic sections and differential calculus, then there is just a natural comfort level to this and this. Even then, as far as this exam is concerned, you should take all of these topics, put them in the bag, and then go here. All questions are coming, they have a +3, -1 framework to them. Get them right, it is +3. Get it wrong, it is -1. If it is type in the answer, it is 0. The +3 here is on an average easier to get than the +3 here. Less time consuming, less risky, you don't get stuff wrong, all of that. And so put this in the bag before going anywhere else. And so as far as the preparation is concerned and the percentile is concerned, let's see if we can do this slightly more diagrammatically. And so as far as percentile is concerned, suppose you say in this chart we have marks or number of questions. Okay. And here you have percentile. Say we have 5 questions, 10, 15, 20, 22. 22 being the maximum observed number, right? If you get 8, 9 questions, you attempt and get all of them right. So suppose you have percentiles here, you have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. You get 8, 9 questions, you're sitting at 90th percentile. Okay. If you get 5, 6, you're sitting at 80th percentile. So the curve will look very absurdly something like this. Right? To get to a 90th percentile number, you need to absolutely be the king of arithmetic and very little else. Keep that in mind. I cannot emphasize this more. Your quant journey is going to sit on a giant strength, on a layer of arithmetic, on top of which you add different things. And so arithmetic is what you start with, then you add other layers on top of that. Right? If you have arithmetic alone in the bag, a route to 90th percentile is charted. Direct, simple, straightforward. If you're really comfortable with arithmetic, naturally you'll go on to algebra, number systems, geometry. Chances are those will be easier to tack on, to add on to the system. Your route to 95, 97, 98 opens up after that. And so topic sequence, you have to think about what sequence you should do the topics on. First, definitely is arithmetic. Next has to be algebra. Then probably number systems. Then probably geometry. A while ago, I was continuously saying start with arithmetic, then go to algebra or geometry, and then tack on number systems at the end. I've had my mind changed, looking at the data and listening to people. Algebra is beginning to play, or not beginning to play, is more foundational because it has an impact on arithmetic and number system. There are questions in these topics that talk about X and Y. So if you're not comfortable with X and Y, you're leaving too much on the table. Better to add that on to the system. So logarithm questions are not talking about what is log 1000 to the base 0.1. They're frequently talking about log x to the base 2 plus log 2 to the base x is 5 by 2. How many values can x take? So you need to get comfortable with algebra to attack those logarithms and exponents questions. So therefore, algebra importance comes straight after arithmetic, because you have to get comfort with x and y to attack this and this. Geometry stands alone. Geometry is the bedrock for trigonometry, mensuration, coordinate geometry, but becoming comfortable in geometry does not have a payoff for arithmetic or number systems, and vice versa. And so of the 4 chunks, probably geometry can be the one that you come around to a little later on. And so arithmetic first, algebra next, number systems third, then geometry. That would be my preferred sequence. What I'm dead sure about is to take arithmetic in the bag and put it in, be comfortable without moving anywhere else. The order within these 3, it's all right. Suppose you finish arithmetic and you really love triangles and angles and circles and polygons and quadrilaterals, go to geometry. That's all right. Suppose you love permutation, combination, probability, you love factors, factorials, thinking about prime numbers, composite numbers, HCF, LCM, go to number system, then come to algebra. That's all right. But do not take your train to other stations without becoming the absolute doyen in arithmetic. And that's kind of not negotiable. Take arithmetic, put it in the bag before going anywhere else. Fine. Lovely. Now I'm going to talk about kind of time spent. We'll talk about it in kind of two different axes. I'm going to say, hey, time spent learning. I'm going to think of it like in terms of like a rectangle. So here I would talk about learning time, then revision time. Put it as two different categories. So early on, your learning time is high, revision time spent on revision is low. As you go further and further, revision occupies more and more space, learning occupies less and less space. And so the way I would classify it, if I have to put it thematically, say, hey, draw a line like this. This axis is time. Suppose you're starting now. This is day 200, day 100, day 50, day 150. And when you start the first month or so, completely, utterly dominated by arithmetic, learn, and put that in the bag. Completely, comprehensively. Become super comfortable with percentages, profit and loss, split time distance, races, ratios, mixtures. Don't stop with that. Spend another 25 days, get arithmetic in the bag. The first layer is to learn, second layer is to become super comfortable. And here, you will be even revising only arithmetic. Get that, become the king, spend a month and a half, but be the person who can reach out to very difficult levels of arithmetic, where your speed is very good, where your mind automatically thinks of patterns, where you can think about, oh, something is down 20%, is 4 by 5, then it's increased by 30% into 1.3. You can do all that naturally, comfortably, quickly, really ridiculously on top of things. Right? Then on this, you add algebra here, while continuing to revise arithmetic. Then at this point, you add maybe number systems while revising algebra and keeping one eye on arithmetic. Right. To this, we add geometry, revise number systems, revise algebra. Finish off geometry, revise number systems, revise algebra, revise arithmetic. After this, you finish off whatever is miscellaneous, focus entirely on revision. Obviously, as you go further and further, more of your time will be taken up by mocks running on a parallel track. There also you'll be learning all of this. Fine. So just wanted to talk about the same set of ideas slightly differently. If you're used to conditioned to thinking about in very linear fashion. In April we do this, in May we do this, in June we do this, in July we do this. I thought the allocation of time based on level of importance to topics, that idea, that funda was important. Sit on arithmetic before going elsewhere. Understanding what are the weightages given to these different topics, that is important. And having a sense of how you should start with the bias to preparation, you should end with a bias to revision is important. And so, which is why I thought I'll depict it in a way where we drive home that point. Sit on arithmetic before you go anywhere else. When you go to other topics, keep revising arithmetic. Whatever you learn, spend lots of time revisiting that. Finish off with 50 days to go, where you're focusing completely on revising and automating ideas. And so this would be, like I said, a thematic representation. Coming back to our first point on this graph, right? This can take you to 90th percentile rather comfortably. Right? This plus this can take you to 99th percentile. And then you add. Having said that, anyone who's ambitious cannot have topics left behind, because the moment you say, look, I'm not touching geometry, right? I'm not touching reminders or number properties, you'll find yourself in a position having to chase the tougher and tougher questions in this. There are 9 questions in arithmetic and maybe 6 in algebra. Right? It could so happen that the 8th and 9th questions in arithmetic, 8th and 9th toughest questions, if you arrange them in hierarchically difficult, easy to difficult, the first 3, 4, 5 are nice and simple. But the 8th or 9th toughest questions, the last 3 or 2, are far tougher than the 4 simple questions here, 2 simple questions here and 2 simple questions here. And if you cut yourself off topics, then you're going to say all levels of difficulty in speed, time, distance, I will definitely do. And last year there was a question on averages, a darn simple topic. There's nothing to do here. And but average age with boys and girls and all that. And that question was so difficult. It'll probably be among the top 2-3 toughest questions in the entire syllabus. A simple topic. And so you should leave some topic. Then the pressure to cover everything in any one section just shoots up. And then in the exam hall, you look at those average questions and say, look, I need to get everything in arithmetic right because I practically don't know anything else, and grapple with it for 8, 9, 10 minutes, killing your overall score. If you have other things to fall back into, then you can say, look, hey, this question seems tricky. Maybe I've missed something, but I don't need this 8th question from arithmetic. I'll skip that and chase this. And anybody who's ambitious and aiming for a 99th percentile, there is technically a route to getting that many marks with doing only these two. The more practical route is to have sufficient grounding in everything. Don't pick and choose your topics early in your preparation journey. It's foolhardy and sometimes lulls you into believing that you've got it. And so arithmetic is the starting step. It is not sufficient in and of itself. It is sufficient to get you to 90th percentile. But I'm guessing that most of you will have an ambition of saying, I need to go beyond that. In which case, it's not sufficient, because I might tell you sitting here that 8 or 9 questions come here, you get 9 questions right, that 93rd percentile, what's not to like. But then 8th, 9th, 7th, 8th, 9th questions in arithmetic are going to be tougher than 3 questions, 2 questions, 3 questions here. So if you cut off topics, then you have to get everything right in this, and that becomes tougher. And so start with this, move to this, and then pick and choose. The sequence in between these 3, that's all right, you can pick and choose. But it has to start with arithmetic. You have to put that in the bag and then say, look, I've got this. Then build layers on top of that. And so quant can sometimes dominate preparation for far too long. Till about September, October, you're preparing quant so much that you forget that it's only 1/3 of the paper. And if you get 1/4 of the questions in 1/3 of that paper, you've cleared section cutoffs. There could be a magical route to getting 99.5 without really knowing what functions or trigonometry is. And especially if you have that kind of profile where you're very comfortable with logical reasoning, puzzle solving, very comfortable with language, but math doesn't come naturally to you, then you should tailor your preparation to ensure that you're not consumed by the vastness of quant. Sometimes quant can dominate preparation. You go and sign up for a course, 65%, 70% of the classes are only quant. When the mocks and analysis and discussion and test series are evenly split, but the classes have a quant bias. And so therefore our minds can get conditioned into thinking that quant is the ball game. It's not. Keep that in mind. I've given an entire preparation for quant, and I'm ending that by saying, look, quant is important. Quant occupies a lot of the mind space because the syllabus is vast and you have to have a plan to go towards cracking that. But don't let your mind be completely consumed by quant. So if you look at this schedule that I've put here, and you've said, look, there's 200 days to go. Till about day 75, you can be thinking topic by topic. Fine. But the moment you're here, you should be thinking more and more in terms of your overall plan, how many mocks you take, where are your marks going to come from, what percentile, what combination is going to give an overall 98 that you want, whether you're quant strong or verbal strong. You have to take the more 10,000 feet view and think of it at a mock level and an overall paper level rather than at a trigonometry level and a functions level. And you have to make that transition very much after day 75 or something. Till for the first 2.5 months, you can say, look, I'm going to learn parajumble, verbal, reading comprehension, Venn diagram puzzles, arithmetic, algebra, that world. Soon enough, you should say, look, only 4 months to go. Now I'm not going to do topic by topic only. I'll revisit topic by topic. I'll add on fundas topic by topic. I'll practice topic by topic. But to me, the overall paper speaks at an overall level today, from today onwards. So you have to make that transition as well. So don't get consumed by quant. And getting consumed by quant is one of the cardinal sins of preparing for this exam. Don't fall into that trap. Super guys, hopefully we've given you some starting steps to think about this section, which was the idea. We'll be doing a series of videos on building on this, where we talk about how to prepare for arithmetic, how to prepare in algebra, how to prepare for geometry, how to prepare for number systems. What do those individual things mean? We'll be adding those layers onto this. I'll catch up with you guys again in those videos. Best wishes.
Hey, hope this video was useful. For more useful content, sign up with 2am for a 40-hour free course with us. All the best.